Right, sequences questions here, and the first one actually has a little something to it. We can see that these are not going up by the same amount. It is not a linear sequence. The first two terms have a difference of 3, and the second two have a difference of 5, and the third two have a difference of 7. We can see that the difference of the differences is 2. The amount it's increasing by is going up by 2 each time. So we follow it with 9 and then 11 to increase by, which gives our next two terms is 22 plus 9, that's 31, and 31 plus 11, that would be 42. So a term like that where the difference of the differences is constant is actually a quadratic term, but in this case we don't, quadratic sequence, sorry, in this case we don't actually need to work out anything to do with that. Okay, the next term should be fairly easy here. We can see the numerators are going up by 1, so the next numerator will be a 6. Denominators are going up by 2, so the next one will be 13. Now, to work out the 50th term, personally I'd find the nth term of the numerators and the nth term of the denominators, which is probably the fastest way, but there are many other ways. So if it's going up by 1s at the top, that means it's going to be something to do with n, but it's not just a term. N plus 1 along the top there. So the first term is 1 plus 1, second term is 2 plus 1, etc. Our denominators are increasing by 2, so it's something to do with the 2 times table, or 2n, but I can see that it's bigger than 2n, bigger than the 2 times table. The first one's 5, then 7, so they're all 3 bigger than the 2 times table, is the way I think of it. So 2 times table plus 3, 2n plus 3, that's what we do. So to find our 50th term, we just need to sub n is 50 into this. So our numerator will give us 50 plus 1, that's 51. And our denominator will be 2 times 50, that's 100, plus 3, so 103. This time we're actually being asked to find the nth term. So let's have a look what's going on. We're going down by 4, down by 4, down by 4, so it's a linear sequence. That means it's similar to the negative 4 times table, is the way I look at it. So the negative 4 times table goes negative 4, negative 8, negative 12, negative 16. I can see each one of the terms written in black here is larger than each of the terms there. In fact, they're all the same amount larger as well. They're all 21 larger. So our sequence is negative 4n, that's negative 4 times table, the bit written in green, but it's bigger than that, it's 21 larger than that. So there are your answers to question 1.